sorry about that. And I'm sorry that this has gone over a little bit. But there were some issues at the beginning. So this is our last example here. And it is complex conjugates theorem. And basically what the complex conjugates theorem tells us, like we already saw in the previous example, is that when you have a zero that's a complex number, they're always going to come in pairs. So if a plus bi is a zero, then its complex conjugate, which is a minus bi, is also a zero. In other words, we're going to say complex zeros always come in conjugate pairs. So that being said, they're asking us an example for write a polynomial function of least degree with integral coefficients. And by the way, that means that all of the coefficients have to be integers, no fractions allowed. And of which the zeros include -1 and 5 minus I. So the part that you're supposed to know from this is that we have a -1, 0. Now this is going to be, that's going to be one of our real zeros, a 5 minus I, which means that 5 plus I also has to be there. So even though they didn't tell you that 5 plus I is a 0, you're supposed to know because they always come in pairs. So that means we're going to have 3 zeros. And that means that when they ask us for a function of least degree, we're going to need a function that has x to the third power. That's going to be the least degree. So we kind of already know how to do this stuff. You take each of the zeros and make it into a factor so that the -1 becomes x plus 1. And then we're going to keep these numbers together and we're going to say x minus 5 minus I and x minus 5 plus I. Okay, so always want to keep the complex zero together before. Don't try to distribute -5 plus I. It's just going to make things more complicated later. So it's always going to be that way. Now we want to multiply these out first because we don't want there to be any i's. They want integer coefficients and i's don't count. So this is not really complicated, but you do have to keep track of what you're doing. So we're going to basically FOIL this. We're going to say first times first is x times x, that's x squared. And then outside times outside is x times -5 plus I. So that's going to be -x times 5 plus I. So we're going to take this x and this negative, that's -x, and then 5 plus I. And then our inside times inside is going to be x times negative again, so -x, and this time 5 minus I. So it is slightly different from the previous one. And then last times last is going to be negative times negative, which is positive, and it's going to be 5 minus I times 5 plus I. Okay? Now, at this point, you can actually try to distribute the x to the 5's and stuff and see what happens. You're going to get -x times 5 is -5x. -x times I is -ix. -x times 5 is -5x again. And -x times -I is +ix. And then over here, you're going to have a difference of two squares, a minus I and a plus I. And remember that we said that when we have that, you always get plus a squared plus b squared. So a is the 5 and b is the coefficient of I, which in this case is 1. So you go 5 squared plus 1 squared. So what you're going to end up with is x squared. You have -5x and -5x is -10x. Your x squared is already there. Your -ix and your +ix are going to cancel, and that's nice because you don't want those i's anyway. And now you have 5 squared, which is 25, and 1 squared, which is 1. So 25 and 1 is 26. And here is my polynomial. Oops, not done yet. That's my quadratic. That takes care of all of this piece right here. So what's supposed to happen when you do that is it's supposed to cancel all the i's. You should have no more i's in your answer at this point. And our last step is to multiply it by x plus 1 to get our cubic, which basically means I'm going to take and go x times x squared, x cubed, x times negative 10x, which is negative 10x squared, x times 26, which is positive 26x. Then we're going to go 1 times x squared, which is x squared, and I'm going to put that right under the other x squared, so I can add them later. And then 1 times negative 10x is negative 10x. And 1 times 26 is 26. So now we can add up our like terms and get our final answer is x cubed. Negative 10 plus 1 is negative 9x squared. 26 minus 10 is 16x. And then plus 26. So here we have our polynomial of least degree, which is a cubic, that has the zeros negative 1, 5 plus I, and 5 minus I. So that is how you do that, and now I will let you do this little guy on your own, and once you have completed this example, you will have completed your notes for today, and I will see you in class, and thank you for watching.